Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to my product development series with the Shredder. This is part number 27 of the Shredder, and also I forgot to mention today I was able to take the chuck off of my drill motor. So basically what you do is you open the chuck up all the way, and there's a screw on the inside, and you just loosen up the screw. And then you could put the biggest Allen wrench you could find inside of the head, and everything on there is left-hand thread. So actually, tightening is loosening, and loosening is tightening compared to a regular one. So if you want to loosen, you go clockwise. If you want to tighten, you go counterclockwise. Same thing with the chuck. The chuck is actually threaded on, and then the screw holds it on to the thread. Keeps it from unthreading. So once you take the screw out from the inside, then you could chuck up an Allen wrench to the drill motor and push the drill motor on the table as hard as you can, and then hit it with a hammer or a soft mallet. Hit the tip of the Allen wrench. So you put the Allen wrench with, the Allen wrench is like an L. You put the short end of the L inside the Allen wrench, and you have the long end stick out. You smack the long end with a hammer, and that allows you to unthread it. Stand by, cat wants to go out. Give me a second. When my cat comes back, I can talk louder. Ava's asleep. My niece in the other room. So yeah, you have the Allen wrench stick out. You have the short side chucked, and you have long side stick out. And you smack the long side, the tip of the long side, with a hammer. Obviously the right way. You want to hit it clockwise. Clockwise will loosen, counterclockwise will tighten. Obviously this is with respect to the chuck, which is basically the Allen wrench. With respect to the Allen wrench, you want to hit it clockwise to loosen, counterclockwise to tighten. And then you should feel it just like break free, and you just thread it off. So now we have, with the thread on it, I don't know exactly what thread it uses with that or the screw. So I'll have to look into that as well. Obviously use one of my dies inside my Harbor Freight tap and die set, and use the pitch gauge to figure out the pitch. So in the meantime, in order to get to that, we need to finish this. So let's go ahead and do that. Alright, so let's see, how are we going to put in, and then we can kind of cap it off with the drive gear. And obviously drive gear is going on the side that has it sticking out the most. Okay, so basically what I'm thinking that is, the distance from here to here is 12 thousandths, so we need to drop okay. So now that should be good, and basically what we want to do with this guy is we're going to mount it to basically the top of the bearing, not that insert. To the top of the bearing. Now we should be good. There we go. Okay, so now let's mount this thing in and see if we get to mesh up. And look at that. Perfect. And there we go. Obviously, as you see, I moved them a little bit closer. I've adjusted for this in the tolerances when I sent it out, and they do seem like they will work pretty well. So let's finish this up so we get to the part where I made the boo-boo. So basically what I'm thinking with how I'm going to mount this is mount this here. That's very strange. Why did I do that? Oh. Oops. It's 1 half moon. Okay, now this basically needs to go over 1/4 inch, right? Yeah. 1/4 inch. And I'm forgetting one thing. I forgot to change those guys to a revolute. We can do that later. These pieces in here to a revolute. So that's okay. Fine. The funny thing is that what I'm showing you right now is actually how I build it in real life, which is pretty cool. So this is the tricky part in real life, because basically you have to put these in here and you have to make sure that they're all squared up before you put the walls on, before you put the sides on. And when you put the side, and then basically this is sitting flat, and at this point, and then at this point you can't really put, you can put a clamp on it, but you just can't put very much force. So you want to put a clamp here and a clamp here and a clamp on the front just to keep it together so it doesn't come apart. But you can't put very much force because then the whole thing comes apart pretty much. So make sure that you do not let it come apart on you. And if you don't, you should be okay. Up, and here comes the fly. Fly's back awake again. So basically what I'm going to have to do to remedy this issue with the side is I'm going to have to make another one, including the holes, because again I'm going to design everything off of those holes. So I'm going to have to go through and redo that. So another thing that I would like to do is I would like to spend some time over the weekend to maybe even add some holes in the shredder itself, the shredder head. So I will do that as well. In the front, because my dad brought up a good point over here on the front side, is to have some holes so that when you so that you can put a finger guard there so you don't pinch your fingers in the blades. You know, obviously I'm assuming that somebody that uses this has got more common sense than that, but you know, I could be wrong. Okay, now here's where it gets a little tricky. Let's see if it'll flip. And nope. Okay, so now what I'm going to do on this, I'm just going to copy. And I'm just going to move it back. Oops. Oops. Oh, I know why it's doing that. Go away, fly. You're annoying. Stupid fly is flying around my head. God dang it, stop doing that. And it looks like I need one more. And one more. And there you go. Alright, so now you'll be able to see, well, on the other one you were able to see that it doesn't quite work. For this length here. But you see that these barely even fit, right? That these blades, the blade right there barely even fits past. So now we do left and right plate. And basically what I'm going to show you here is if we go from, if we do this to this, we are quite a bit short. Half an inch, obviously. Let's try this. Oops. Okay, then we go back here. And like magic, we are back in the right spot. Okay, and then we drop in another one. And we anchor it. To one of these sections here. And we're going to flip it. And we're going to go out 0.25. And there we go. So now, if we do the same deal, we close this off. We do a sketch on this top piece. And we are going to project this piece. We're going to draw a line from here to here, and if we go from here to here, we notice we have 5.15 inches. So we got 15 thou clearance. Obviously, we have a tolerance now, where there is quite a bit of length here now. Now this is like 535, so like 35 thousandths. Yeah, so let's go back here and so let's have that selected. Revolute. 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 Okay, now what we want to do is we want to do this one and this one. So this one, cool look right there. So this one, what we could do, get rid of that rigid group, get rid of that rigid group. Yeah. So it's this one, and I keep using shift, but it's control. And we're going to you have to do components. These two. With these two. Okay. And one more. Oh, let me just click on them. Sure. Okay. Now it should work. Okay, I think we are done. Oops. So now we finally have a fully assembled. Let's call this left assembly. Okay. Drive joint. Interesting. Anyways, I'll look into it later. But now we fixed the issue, so now we need to increase this to 6.5, and now we have at least 15 here. Obviously, like I said, I know it's more. It's actually more along the lines of 30 to 40. Okay, so now we have that done. So now we can now I can basically make this plate, and then once I put it together, I will update it here, and we'll make a couple holes here after I think about it this weekend. So we'll do it this weekend. I'll probably have to update you guys on what's going on after that. Alright, so now that we have that done, let's go ahead and drop this. Let's go ahead and drop that. Let's go ahead and drop that. This is gonna have to be updated, so let's update it. There we go. Now this should be 6.5. Yep. Alright, so let's go with motor. So what this means is that this indeed can happen, because I do have a piece of 3.5. Piece of 3.5 by 3.5. So let's place it right here, very gently on the table. And the inside is exactly 3.5 1/7 thou. But the issue is that it has a giant seam in it. Oh, is it a little low the other way? I think there's a little bit of crust on the inside. It's like 3 thou under, which I think is some of the junk that's in there. Okay, so now that's good. And then obviously this, I believe, is 1/2 inch thick. Well, actually it's a little smaller. So what are we looking at outside here? 3.984. So it's a little bit smaller than 1/2 inch wall. It's about 0.238 on this side, and yeah, about 0.238 on this side. It's a pretty thick piece of plate, and it has a radius around the corners, and the radius is about 5.265. 5.265. Divided by 2. And I kind of eyeball it. Looks to be about a 30 or so. Oops. Looks to be about right. And then now the inside. Let's take a look here. I'm going to say about a 20. And now when we shell it, we're going to ask for 0.238. There we go. And that's basically what it looks like. So this is now our mounting bracket. And that is very like this piece of steel I have right here in front of me. And this piece of steel that I have in front of me is, the sample here is about 7¼ inches long. So we can make a couple test pieces out of this. On one side it looks like I have some test welds. I might have been doing that to test the new Miller when I bought the Miller welder. I mean, when my dad bought the Miller welder, so that's probably what I did on that piece. Actually, you know what that is? That's for, we have some post that we're gonna do for the, for a new entryway into our carport. I mean, into our RV access on the side of the house. That's for the new fence. And so basically we bought giant poles like that, and I dug a big ditch, and we concreted them all the way down the ground. So that's what that's from. That's a leftover piece, and we're going to use it. So let's see. Oh no. Looks like that sucks. Oh, it was this one. That was this bracket, but earlier. yeah. So here it is. Okay. So now basically if we have a second to do it, let's look to see how we would do it. So basically what I'm thinking is that this guy's actually going to mount with the handle in to give it the biggest offset room for gearing. So now the question is, with the 3/4 here at the bottom, how far is it? So how are we going to go about doing that? Well, we could do it from this edge here. So let's use both calipers here. One caliper, my cheap carbon fiber one, as a straight edge. And we're going to go across here like so. I'm going to turn it on. One 1.080 from this point to the top. 1.080 and a fifth. Okay, and then that's to the top. And now this guy is 0.788. And so that is the point of offset there. Now if we go from here down, it's 2 inches and some change. So what that means is that if we go back and we go into the assembly, where to go? There it is. .015. .015 plus this one. So that's about 4 inches. About 4 1/4 inches, a little bit over 4 1/4, almost 4 and yeah, it's a little bit over 4 1/4. So that means that we have quite a bit of room to have these these 2 gears, 2 step down gears, to get that appropriate gear ratio. Alright, so that's it. Next video we will be designing this gear ratio, and we will go from there. Thank you guys for watching. This has been Steven from Legit Tech Tutorials and the Legit PC. Thank you guys for watching. If you like this video, please subscribe for more videos like it, and I'll see you guys next one. Take it easy. Peace.